Alright, so first it says find the first and second derivatives. So I'll just put it over here. Oops. Here we go. So if y equals 2 sine x plus cos 2x, when we're finding y dash, we want to find the derivative of sine x, so that's cos x. And cos goes to negative sine, and we need to times by the 2 as well. So y double dash, cos goes to negative sine, and sine's going to cos, and we need to times by the 2 at the front. So we're going to get that. Alright, so then we have to show that for y dash equals 0. Well, let's make y dash equals 0. So there's our y dash there. So if we make y dash equals 0, oops, what we are doing is saying that 2 cos x minus 2 sine 2x. So 2, now sine 2x is 2 sine x cos x. So I could change sine 2x to 2 sine x cos x. So I'm making that equals 0. So they both have a 2 and a cos x in them, those both terms. So 1 minus, and this one's got a sine x left in it. So if that's equaling 0, we're showing that either cos x equals 0, we'll solve that, or sine x from the bracket part will equal a half. Okay, now for cos x equals 0, this is in, it just says, it doesn't say what interval, but later on you can see we're going to look in the interval from negative pi to pi. So I'll look in those intervals. So x, so negative pi to pi, so we're going all the way around here to pi and all the way around here to negative pi. Okay, so for cos x, although cos x, I will just draw it. So cos x goes like that, pi being here, and minus pi being here. So that's negative pi on 2, and that's pi on 2 there. And that's, oops, that's 1 and minus 1 there. Alright, so where does it equal 0? Here at plus or minus pi on 2. So we've got both of those. For sine x equals a half, in those quadrants, we know the only one we want because sine is positive in only the first 2. So we've got pi on 6 being 30 degrees, and that means 5 pi on 6 in the second quadrant would also give us a half. Alright, so then, okay, so find stationary points in that interval. Okay, so these are where our stationary points are going to occur, and then determine their nature as well. Alright, so let's, okay, actually let's get rid of that because we've done that now, and we know these are the points we're interested in. So I'm actually going to look at the sine curve between pi and minus pi as well, just so I can see that easily. Okay, so oops, what happened to my pi on 2? There we go. So if I look at, let's say at x equals pi on 2, what would y double dash be? So here's y double dash here, and we're saying it's minus 2 lots of sine pi on 2. Sine pi on 2, which is here, is 1, so that's just lots of 1s. Minus 4 lots of cos of the double angle, so cos of pi on 2 lots of pi on 2 is just pi. Cos pi, so here's cos pi here, is negative 1. So we're going to get negative 2 plus 4, so that's 2, and that's greater than 0. So it's going to be a minimum stationary point. And that point is at pi on 2. And then if we look at finding the y value, so let's put it in this equation. I'll put it in red here. So if I put that in there, I'm going to get 2 lots of sine pi on 2s. So 2 lots of sine pi on 2, of course, is 1, plus cos of pi, and cos of pi is negative 1. So 2 minus 1 is 1, so that's going to be 1. So that's a minimum stationary point. Minimum stat point. There, okay, so let's also try at x equals negative pi on 2. So in the same way, I'll do y double dash. So this time for y double dash, we've got negative 2, lots of sine negative pi on 2. So here's negative pi on 2. So that's negative 1 minus 4 lots of cos negative pi. So negative pi is over here, and that's negative 1. So we've actually got a positive 2 and a positive 4, which is a 6, which is greater than 0. So again, it's going to be a minimum. So what have we got? Negative pi on 2. And if we sub that in, and then I'm going to say that is a minimum stat point. Get that ready. All right, subbing in negative pi on 2 into, of course, our red box to find our y value. So we've got 2 sine negative pi on 2, so sine of negative pi on 2 is over here, negative pi on 2, which is negative 1. And then we've got plus cos of negative pi is negative 1. So we've got negative 2, negative 3 there. All right, so let me rub those out. Okay, so remember x equals pi on 6 and 5 pi on 6 is also, so here we go, x equals pi on 6. Let's do that one first. So y double dash being minus 2, again we're looking in the pink box at y double dash, minus 2, sine of pi on 6, sine 30 is a half, minus 4 lots of cos 2 pi on 6, so pi on 3, cos pi on 3, cos 60 is a half. Putting that together, we've got minus 1, minus 2, so we'll get minus 3. So therefore, you can see it's going to be unhappy. So this is going to be a maximum stat point. Maximum stat point. So what is this at? This is at pi on 6. And then putting it into our y equation, we've got 2 sine pi on 6, sine 30 is a half. Plus cos of pi on 3, which is also a half, so we're going to get 2 times a half is 1, 1 and a half, so 3 on 2 is what we're going to get there. Alright, so let's do the last one. We're running way out of room. Can I still see that? Not really. Hopefully you can still see it. Okay, so at x equals, now this was 5 pi on 6. So y double dash, you can do this yourself. You're going to get minus 2 lots of, it's going to be a half again because we're in the second quadrant, sign is still positive there. Minus 4 lots of, we're now in the fourth quadrant because, and I'll just show you this one. So we've got 5 pi on 3. 5 pi on 3 is almost 2 pi. Just pi on 3 gap before we get to 2 pi. And that fourth quadrant cos is positive, and cos of 60 is a half. So putting that together, we have a minus 1, minus 2, so that's minus 3, and minus 3 is less than 0. So if minus 3 is less than 0, we're looking at a maximum again. So we're looking at 5 pi on 6 being a maximum stat point, and it's a maximum stat point if we put 5 pi on 6. We get 2 lots of sine 5 pi on 6, which is a half, plus cos pi on 3, which is a half, so we get 3 on 2. Okay, so now you've got all those points, we can actually sketch the curve between minus, so I'll keep that, minus pi and positive pi. Alright, so let's get rid of these. So we've got some room. Okay, and we want, let's go something like this. So we want, let's go in pi's on 6s. So pi on 6, 2 pi on 6, 3 pi on 6 is the same as pi on 2, 4 pi on 6, 5 pi on 6, 6 pi on 6, which is pi, and then we'll go over to minus pi on 2 we need, oops, minus pi on 2 and minus pi. There we go. So we know, and I'll put a little dotted line here across at 1. And then, so we do know that minus pi on 2 minus 3 is a point, which is minus pi on 2. Let's say minus 3 is down here, minus 3. So that's a point. Pi on 2, 1 is a point, and that's a minimum point. Pi on 6, 1.5. Let's just go a bit higher there. Whoops, 1.5. And we've got 5 pi on 6, 1.5 as well. What we could do is sub pi in. So when we sub pi in to our y equation, we actually get a 1. So I'll put that in. When we sub negative pi in, we also get a 1. When we sub 0 in, we also get a 1. So all those points need to be gotten through. So something like that. That was bad, but that. So it's only between negative pi and pi. So there's my sketch of the curve.